From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show. Today on the Fragmented podcast, we're talking about item 16 of the Effective Java book by Joshua Block. Now, item 16 is favor composition over inheritance. Now, if you're just joining us on this wonderful journey into the Effective Java book, just a quick note to you, there are 15 previous episodes where we talk about the first 15 items. Our goal is to cover all of the items in the Effective Java series over the course of the Fragmented podcast. And so here is item number 16, favoring composition over inheritance. Now, and you've probably heard this term and seen it various different places all over the web, in conference talks, and so forth. So what does this actually mean? Now, let's kind of get into some examples and talk about inheritance first before we understand what composition is. Inheritance in this situation is referred to as inheritance to be when one class extends another. We're not really talking about interface inheritance when a class implements an interface or one interface extends another. We're not talking about that. We're talking about when one class extends another. Now, what happens here is when we extend one class to another, we can run into various different problems. I've been in various different companies consulting, and I've seen humongous object graphs where there's maybe 10 different superclasses up the object chain. And if I need to make a change, it's a humongous spaghetti code of changes. I've even seen situations where I'll be in the middle of the inheritance hierarchy and I'll see that the class is doing something to undo something that was done 3 levels up inside of the inheritance hierarchy. What this basically is showing us is that at some point in time, inheritance doesn't make sense and it starts to break down because it gets a little bit fragile. And so we have to be really careful of it. And I think the best way to explain that, and this is what Joshua does in the book actually, is talk about a real world example of how this can kind of break down. So let's really make this concrete with a real example here. And I'll do the best that I can to explain this over a verbal, audible medium, such as in a podcast here. So let's say that you have a class and your program, that class or whatever, uses a hash set. Now, for whatever reason, you need to tune the performance of your program and you need to ask the hash set, hey, hash set, over the lifetime of how long you've been around, how many items have been added to you. Now, we're not talking about the size. The size will be adjusted when an item is added or removed, so it'll go up and down. We need to know the total number of items that have ever been added to the hash set. So there may only be 14 items or 10 items in a hash set, but over the lifetime of it, maybe it's had 150 in it for whatever reason. And that's what we need to use to help tune our application. So to do this, we've kind of thought, hey, it would only make sense to go ahead and extend hash set. I need to be able to keep track of how many items are added to the hash set. So we're just going to create a class called instrumented hash set, and it's just going to extend hash set. And inside of this class, we're going to have a private field that keeps track of the count of how many items are added to it. And to do that, we override the add method of the hash set and we override the add all method of the hash set. Seems pretty simple, right? When the add method is called, we increment the counter by 1. And then when the add all method is called, it takes in a collection itself. And we just get the size of the collection and add that to the count as well. Looks pretty reasonable. Sounds pretty reasonable. Let's go ahead and assume that we create a new instance of this new class we had created called instrumented hash set. And it takes in type string. And then we're going to call that just S for like set. And we'll say, hey, set dot add all, and we're going to pass in 3 values, snap, crackle, and pop. And these are 3 strings. So we would expect that our little counter that we had, let's create an accessor for it called get count or whatever. And we say, hey, instrumented hash set, I need to let me know how many items have been added. So I'm going to call your get add count method or your get count method, and it's going to return back, what would you expect? Well, we added 3 items, so you'd probably expect that it's going to return 3. Well, you would be wrong, and so would I. And why would you be wrong? Well, the devil is in the details, as they say. If we actually take a look at hash set's add all implementation, we'll see that in turn, inside of the add all method, it's actually calling the hash set's add method. So that can be a real bummer. So why is that a bummer? Because our add all method just increments our count by the size of the collection. We passed in 3 items. We're going to say, hey, the count is 3. But underneath the hood, when we call the superclass to have it actually add the items to the collection, it's going to call the add method itself. And that in turn increments the counter by 1 for each item every time it gets called. So in turn, it's going to do it 3 times, totaling 6. So when we add 3 items using the add all method, we actually get 6 as the total add count. Well, that's wrong. That's a bug. That's going to be a problem. So let's think about this further. Okay, we've run into this problem. We can fix this. We're smart. Let's decide to fix this. And we're going to go ahead and fix the subclass by eliminating its override of the add all method and so forth. Now, that would work and so forth for a little while, but this is kind of an implementation detail, and maybe we need to use that add all method for whatever reason. This makes our class a little more fragile. So what we could do is we could maybe re-implement add all, but we just re-implement the logic ourselves, right? We're smart enough to do that, so we can re-implement that logic to add all the items to the collection appropriately, and then we're not going to double up our count. But what ends up happening is the hash set's original add all implementation is no longer would be invoked. And it doesn't really solve all of our problems because we're re-implementing the superclass details, and which A is difficult, is time consuming, and usually, and this is going to be the big one, it's usually error prone, and you're probably going to introduce all kinds of different error scenarios. And most likely, if the program is using this for some type of security situation, could implement a security hole inside of your application, which, as we know, is a pretty bad thing. Now, these things are all originating from the fact that we're overriding methods. And this can be even compounded further when we have a class such as hash set. And let's assume that in a future version, a new method comes out in hash set that allows you to add by providing a bunch of characters. And these characters are just basically joined together to create a new string. And so you pass in 50 characters and that creates a string, and that's one item in the list. And now that's the new version of hash set. You don't know about that version that came out. You don't know that the server was updated. You don't know that one of the developers on your team is using it in a different part of the app on the the instrumented set class that you've built. And all of a sudden you're getting this one-off error, two-off error. For some reason, the counts aren't adding up. Well, why not? Well, it's because the original hash set implementation has changed from underneath you. You didn't know about it. Again, creating code that needs to be maintained more often, more fragile. You don't know that it's there because we're relying on that actual implementation. And that's because we're overriding these methods, and we're expecting that the folks only use these methods so we can use the instrumented hash set appropriately. Sure, yes, you can go in and update it, but what we're trying to say here is that it can get difficult and error prone and so forth. Luckily, there's a way to avoid all of these problems that we just described. And so instead of extending an existing class like hash set, you're going to want to create a new class and give that new class a private field that references an instance of that hash set. And so this design is called composition because the existing class that we're working with, hash set, becomes a component of the new one. So we could create a instrumented, hash set, or which is called instrumented set for that matter. We create an instrumented set class, and inside of it would contain a private field that references a hash set or a set instance. Now, let's just go ahead and use set, which is an interface. And the reason why we're going to do that is because we can then work with different types of sets. There's like hash set and tree set and so forth. So let's just go ahead and rely on like an interface. And so we'll create an instrumented set class, and it's going to implement a set, and that's an interface. And to implement set, of course, we're going to have to implement all these methods. We're going to have to implement clear and contains and add, remove, add all the ones that are required in the set interface. But if you implement those in your code editor and IntelliJ, Android Studio, whatever, you're going to realize you have empty implementations. Some of them need to return values like a true or false, or you need to return an iterator or a size, an integer. So what do we do there? Well, that's pretty easy. We already have a private field that references that hash set, and we're going to provide that through the constructor of the instrumented set. Anytime we create a new instrumented set, we'll provide the hash set as into the constructor. It will then be a private field that we can then reference. So inside of those methods that we overrode to use the set interface, such as clear or contains, we'll just say, hey, hashset.clear or hashset.contains or hashset.add, and we'll add that value to that. And so again, we're using generics here, and it's hard to explain over a podcast, but hopefully you're getting the good point here. Joshua Blocks actually breaks this down a little bit further. He uses something known as like he uses a forwarding class, and then he uses a composition class. I'm putting it together in one here for the example. But what this is really doing is, you're probably familiar doing this before, as this is known as like a wrapper. We're wrapping this class with existing or new functionality. This is also known as the forwarding method approach. We are then forwarding the method calls to the actual, the parent class. So we have the instrumented set. If someone calls .size, we're actually going to forward that method call to the hash set that we passed in, or to the tree set, or whatever set implementation it was. It said, hey, local private field here, tell me the size of you, and then we'll return that value. And that's known as a forwarding method here. And we're just wrapping that type of implementation. Now, by using a interface, you're probably wondering, why would you need an interface? Well, it's an interface which captures the functionality of the existing hashset class, and it's going to allow us to be a little bit more flexible. So if I want to then instrument a hash set or a tree set or any other type of set instance, then I can just pass it into this instrumented set class, and we'll then be able to do the counts, which you may be wondering, well, where are those counts at? Well, how are we keeping track of how many items have been added to this instrumented set? Very good question. We haven't done that yet. So to do that, we have our instrumented set class, and all we're going to do is where, for example, in the add method where we just delegated the call to the hashset.add, right above it, we're just going to increment the count by 1. That's it. Inside of the add all method, we'll increment the count by however much the size of the passed in collection is. Now, these aren't going to have the same, it's not going to have the same problem that we had before with the interface, with the typical inheritance situation. Well, why not? Because we're not relying on hashset to do the work for us. We're actually kind of delegating the calls down. Now, sometimes this is also known as the decorator pattern as well, because we're actually decorating functionality on top of an existing implementation of a different type. Again, there's various different names that this can kind of go by, but you have actually probably implemented this already and you didn't even know you were doing it. So we're not going to encounter the error because we're not relying on the hash set, and because we're calling hashset.addAll, it's just going to do its work. We're not relying on any internal counters. It's not going to call our methods because we're wrapping the implementation and forwarding the calls to the existing hash set. This is also good, like I said, because then we can use this with a hash set, with a tree set, et cetera, et cetera, et cetera. And it makes it a little bit nicer to use. And so here, this is actually known as using composition over inheritance, because we are composing a class. We have an existing class, which is a hash set, and it becomes a component of our new class known as the instrumented set. So let's reiterate that real quick here. This is called composition because the existing class, which is a hash set, which we had extended before, now becomes a component of the new one. It's now a local private field inside of our new class. It's a component. So we are now using composition to build this class that we need to use for whatever performance testing or whatever. Now, this situation does not come without its own set of problems, and so let's talk about a couple of those. As Joshua Block states here, it's not usually well suited in callback frameworks where object pass self-references to other objects for subsequent invocations, because a wrapped object doesn't really know that it's a wrapper, and it passes a reference to itself via this, and callbacks elude certain types of wrappers and so forth. This is known as the self problem. I'm not going to dig too deep into this. Hopefully, we have really got you hungry to go buy, and if not, you haven't bought the Effective Java book, please go pick it up. We'll provide a link in the show notes. Fantastic resource. You'll learn a ton. Inside of this item 16, there's various links if you're looking at the Kindle book. If not, you can look at I think those notes, the footnotes, and it should provide the links to the self problem. Other issues are some people worry about the performance impact of forwarding these method calls to an existing implementation. Since we're not calling the direct hash set add or remove or whatever, we're actually wrapping them. People worry that it could be, could have a larger memory footprint and could cause a problem. This is one of those situations where, in my opinion, you're probably worrying about it too much, and you probably should instrument your application to see if that's actually the case. Run it through some type of testing algorithm, see if it's really the problem. Now, if you're throwing a thread.sleep in there and you're wrapping it, that's going to, of course, create a slow problem for you. If you're allocating, a huge bitmap inside of one of these wrappers, that's going to be a memory problem for you. So be aware of these situations. But if you're doing something fairly simple, it's probably not going to be a problem. If you're interested, definitely profile it. The new profiling tools in Android Studio 3.0 are fantastic. So definitely go check some of those out if you're using this in Android. It's also tedious to write some of these forwarding methods because we implemented set, which is an interface. We had to implement all those methods. The good thing is it is a little bit tedious. It is extra code that we do have to maintain, but usually it's code if we've written this particular class for a particular use case like this instrumented set, or we're just going to use it for instrumentation or whatever, then in this case, we got to write it once. We really don't have to write it again. We can write unit tests for it very easily. And it's really, it's maintained fairly good at that point forward. Now, there is times when you should use, inheritance. And what are those times? I think the best thing that we can do here is use the example question that Joshua Block provides in the book here. And this is a really good one. This one I've used for a while. And basically it says that inheritance is appropriate in circumstances where the subclass is really a subtype of the superclass. So in other words, Class B should only extend Class A if a relationship exists between the two classes. So what does that mean? Basically, we're saying like, okay, if you're tempted to have a Class B that extends Class A, ask yourself the question, hey, is this B class really a class? Is it really a child of A? If you can't truthfully answer that to yes, then you should probably contain a private instance of A inside of your B class and use some type of composition to make your API or exposed API smaller and simpler. Now, if it is, then go ahead and use inheritance. And this might be a situation of, okay, is an apple a fruit? Well, yeah, it is. Okay. Is a orange a fruit? Yes. Is a bowling ball a fruit? Well, no, it's not. I mean, they're all kind of round in nature, but that's kind of where the similarities end. So we're not really going to use inheritance in that situation. Now, they can all roll, but that's maybe that's something a little bit different. Maybe we need to use the interface in that situation to kind of delegate and compose this a little bit differently. It's also important to note that Java is not perfect in its own little world here. It does actually violate some of this as well. For example, a stack is not a vector. A property list is not a hash table. So there are existing examples of where the Java standard libraries and so forth and various other libraries violate this as well. And you've probably seen this in your code as well where things are violated. And a lot of times you don't even notice you're doing it. Something you inherit it makes sense at the time. You have to keep extending it. Oh, you need to make a change. You make another extension. And before you know it, you have all this huge inheritance hierarchy and you're kind of in a mess and you might need to go back and refactor to use composition over inheritance. There is one final question you should probably ask yourself here is that if you're going to use inheritance, you determine that's the way to do it. Ask yourself, is the class that you're going to be extending have any flaws in its API? Can we think of any classes in the Java ecosystem that might have a really funky or weird API or that maybe has some flaws, as some people would say? I don't know about you, but I'm kind of thinking about the Java date stuff. That's let's take some time and reflect on how beautiful. No, I'm just kidding. So let's just say you're going to wrap the Java date stuff, right? You want to extend that. Are you okay with propagating those same weird APIs into your own class's API? Because if you extend the Java date stuff, date classes, you're going to expose all of that awkwardness that it has down into your existing classes. So all that superclass stuff is going to be pulled down into yours. Do you want that to happen? Or are you trying to make life easier on yourself? Most likely, I'm going to guess you're trying to make life easier on yourself. So in that case, it might be more useful to use composition because then you can actually design that new API that actually hides those flaws. So it might be, Donn's date, and it would just take an instance of a Java date class, and I would make all the calls nice and pretty, which you'll probably actually have those utility classes lying around somewhere in your code base right now to clean up some of the date stuff actually. And this is, the date stuff is not the only issue, but there are various different classes and probably third-party libraries you've worked with that have issues. In that case, composition might be a very valid use case. Now, to summarize, inheritance is great when used appropriately when a genuine subtype relationship exists. So, using the is a type of question to say, hey, is A a B, is B an A, or whatever. Ask yourself those questions when you're about to use inheritance to make sure that it makes sense. Because if you implement something with inheritance, it can lead to fragility if the subclass is maybe in a different package from the superclass and the superclass is not designed for inheritance, or it just doesn't really make sense and you're just trying to hack something together. It may make sense to use composition. Maybe create that wrapper class, use some forwarding. It makes it a little bit easier and it helps you avoid some fragility because you don't have to rely on that inheritance. And if something changes in that API, you're not really relying on that in too details. And so this will allow you to be a little bit more flexible in your application, and we hope that helps you. And we'll talk to you next week. Bye-bye.
That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.